So, systems of equations. Remember we did systems before break. What are systems? Two equations, right? And we solved them either by graphing or using elimination or using substitution, okay? So, we know how to solve it. In the word problems, we have to come up with the equations first. Then we'll solve it using the methods we knew. So, we have two people. We have Alyssa and Beth. They improved their yards by planting rose bushes and geraniums. They bought their supplies from the same store. Okay, so Alyssa is going to be one of our equations, and Beth is going to be the other equation. So let me start with Alyssa. Or Elisa, I don't know how to say her name. She spent $103 on 11 rose bushes and 5 geraniums. Okay, so let me think about this for a minute. She bought rose bushes and geraniums, correct? Yeah. Do you see what I did there? Rose bushes and geraniums. And she spent how much? Now, $103. Now, I can't just leave it as R plus G. She bought how many rose bushes? 11. So that has to be 11R. And how many geraniums? So that has to be 5G. Does that make sense? Yes. We're going to do the same thing for Beth. Okay? Beth also bought rose bushes and geraniums, and she spent $95. How many rose bushes did she buy? And how many geraniums?
5.
And there's my two equations. Does that make sense?
Yes.
It's pretty easy, right? Sort of. So here's my system. I don't need their names anymore, really, but here's my system. What method should I use to solve it? Graphing, right? No, we're not going to graph these. That'd be a pain. I think we could do elimination pretty easily, couldn't we? What do I have to do for elimination? Just multiply one of them by a -1, right? So that would get me -11R. -1 times 5 would be -5G equals -103. Am I going to do anything to the other equation? Nope. So 10R plus 5G, this one's just coming straight over, equals 95. So now what eliminates? The 5G's. -11R plus 10R is just -1R, right? And -103 plus 95, -103 plus 95 is -8. So I need to divide by what? -1, and I get R equals 8. What did I just find?
How many rose bushes?
I just found the cost of one rose bush. So rose bushes are $8. How do I find the geraniums then? Plug it back into one of my original equations. Doesn't matter which one. Pick one that has more reasonable numbers. I'm going to pick the second one because the numbers are a little smaller. So 10R, and what am I plugging in for R? Plus 5G equals 95. 10 times 8 is 80, plus 5G equals 95. Now what? Subtract 80 from both sides. So 5G equals what? 15. Divide by 5. And G equals $3. Not too bad? The solving part should all be review. The only new part is coming up with the equations. Now, whenever you have two things that you are trying to find out, we were trying to find the cost of a rose bush and the cost of a geranium. If you have two things you have to find out, you need to have two equations in order to find them out. If you have one thing you need to find out, you only need one equation. If you have three things you need to find out, you need three equations, okay? We're going to stick with the two things, but just know that that's kind of the pattern that it works with, okay? Any questions about that before I move on? Beautiful. All right, we got two people here, Justin and Sharon. They are selling candy bars. Justin has 30 candy bars and sells 2 candy bars per day. Sharon has 36 candy bars and she sells 3 candy bars per day. After how many days will they have the same number of candy bars remaining? How many candy bars will they each have left? This one's a little different because it's not really a cost per candy bar kind of thing, is it? Kind of, sort of. So let's start off with Justin, just because he comes first alphabetically. So the number of candy bars he has left, I'm going to call C. I don't get very creative with the letters. I like the letters to start with something so I know what I'm referring to. If I used X, then at the end I'd be like, oh wait, what was X? Is that the number of candy bars left? Is that how many you started with? I don't know. So that he has how many candy bars? 30. And he sells, watch this, 2 per day. And I'm going to put a subtraction there because he is decreasing his amount by 2 per day, correct? Okay. So then using that pattern, what is Sharon's going to look like? The amount she has is equal to what? 36 minus 3D because she is selling 3 per day. Do I want to use elimination? I could, but it's set up already for what? Substitution. Because if C equals this, then I can plug this in for C there, can't I? So let's see. 30 minus 2 per day is equal to 36 minus 3 per day. Now, there's 2 letters that we're looking for. We're looking for C and we're looking for D, correct? What do C and D mean? Because there's 2 questions. After how many days will they have the same number of candy bars remaining? That's going to be D, number of days, right? Number of days. And what's C? How many bars they have left. Okay. So let's solve this. What am I going to do here? Right. We need to move things together, right? I'm going to move the 3D so that my D becomes what? Positive. So I have 30, negative 2D plus 3D is positive D. And you could use a lowercase d if you want to. That's fine. No big deal. Now what? Subtract 30. And D is equal to 6. So it's 6 days until they have the same amount left. How do I find the C value? Plug it in. Either one of these two. Doesn't matter. Pick the one that looks easier. I'm going to pick the first one. So C is equal to 30 minus 2 times 6. That's 30 minus 12, which is what? 18. So in 6 days, they will both have 18 bars remaining. So? A little different way to set up the equations. So up here we used elimination. Here we used substitution. I'm not concerned with which method you use. I'm just concerned with, are you using whatever method correctly to get to your answer? Okay. Let's see. I want you to see if you can come up with the equations for number 3. So I'm going to give you a minute to think about that. See if you can come up with your equations there. It's similar to number 1. All right, what have we got? We have rose bushes and what? Pots of ivy. I'm going to do a P just because I think P is easier to write than I. And how much did Kim spend? $204. So what's her equation? 9R plus 12P equals 204. And if you use different letters, that's fine. Okay. What about Anna? How many rose bushes and pots of ivy did she buy?
3 and 3.
She bought 3 rose bushes and 7 pots of ivy, and she spent what? $92. What method do you want to use? Elimination is going to be easier because none of those letters are easy to get by themselves. So how do I do elimination? I need to multiply this bottom one by what? -3. So the first equation is going to stay the same. This one's going to stay 9R plus 12P equals 204. This one is going to become -9R, what? Minus 21P equals negative, what? What's 92 times 3? 276. And now I can add them together, right? So those cancel. 12P minus 21P. Negative 9P. And then 204 minus 276 is negative 72. Divide by what? Negative 9. And P equals what? 8. Yes? Yeah? Okay. So now I take P equals 8 and I plug it back in. So I'm going to plug it in. I'll plug it into the second one. 3R plus 7P, and I'm plugging in 8 for P, equals 92. What is 7 times 8? Oops. So 3R plus 56 equals 92. What do I do now? Subtract 56 from both sides. And 3R equals what? 36. Divide by 3. And R is what? 12. So here rose bushes cost $12 and pots of ivy cost $8. And if I asked you to write that in a sentence, you could say exactly what I just said, right? Rose bushes cost $12 each and pots of ivy cost $8 each. Questions there? So the hard part is coming up with the equations. After that, solving it is exactly the same as we did before, okay? All right, your homework posted on Google Classroom. I did not copy it for it. You do not need to copy down the problems. You just need to read the problems and then solve them, okay? Odd answers should be up there also so you can check your work on the odd ones. All right? Happy studying.